Okay. So I got asked to do a class on geology, most specifically the white rock and the red rock and why they're different. But to do that, I got to go back a little bit. So 260 million years ago, there was only one landmass on the planet, and it was called Pangea. When Pangea started to break up, that's when we started getting our continents to form. When the North American plate and the Pacific plate collided, just off the coast of what we now call California, it started creating the mountain ranges, the Cascades, the Sierra Nevadas, the Tetons. All of those are part of those two plates that collided. And when it did that, it trapped a portion of the ocean off, so it no longer had access to the rest of the ocean. That portion of the ocean was kind of teardrop shaped. It went all the way from Nevada, California, Idaho, Colorado, Wyoming, Montana, into Canada, covered Utah, parts of Oregon, and parts of Washington. I mean, this part of the ocean was huge. That part of the ocean, from 260 million years ago to today, has been shrinking in size because it doesn't have access. So it either evaporates or it soaks into the ground, and it's currently the Great Salt Lake in Salt Lake City, Utah. So that's why we have a salt lake in the middle of the continent, because it was a part of the ocean. So for about that next 80 million years, the wind blew sand in here, and a lot of it actually came from Colorado. So the wind at that time was different than what it is now. From right now, the wind blows pretty much west to east, and so we got wind that flows across our continent. But back then, it was picking it up in Colorado and swinging it up and around, as opposed to left and right. And so a lot of the sand that we have here on the Navajo sandstone actually came from Colorado, or the east side of the United States. That red sand has iron in it, and when iron oxidizes, it touches oxygen, it oxidizes. But to do that, it just loses electrons, and that's what allows it to break down its molecular structure. So if you have silverware in your drawers at home and it gets a little pit in it, it'll start to rust because it's allowing those electrons to escape. And the one way to stop that rust from happening is to give it those electrons back. So there's things here that actually have extra electrons in it, like vinegar. If you take a rusted nut and bolt and soak it in vinegar, you'll get rid of the rust because it's actually giving the electrons back to the rust, allowing it to be whole again as opposed to breaking down. When we have volcanoes here, volcanoes produce hydrogen sulfide. And you can actually buy hydrogen sulfide online. You can even go to Lowe's and Home Depot and they call it iron out or iron be gone. It's just hydrogen sulfide in a can. And it smells like rotten eggs and sulfur. Have you ever been to Yellowstone? So
Yes.
yeah. When you go to Yellowstone, you're standing at the geyser and you smell that rotten eggs and sulfur, that's just hydrogen sulfide. But when you're standing there at the geysers, all the stone around the geyser is generally white. But the further away you get from the actual geyser, it starts to turn yellow and orange and red. And that's because that geyser is releasing hydrogen sulfide, which keeps the stone from rusting, so it stays white. But the further away it gets, the less electrons it has, and so it starts to rust out here. When our volcano erupted, all the sand here in Snow Canyon was actually just packed wet sand. It wasn't stone yet. Our volcano erupted, but it couldn't bust that big layer of granite on there. So it shot that hydrogen sulfide, just like it did the lava. That lava flowed underground, found a weak spot and popped up. That hydrogen sulfide, which was a gas, got shot through that wet sandstone and pushed all that iron out. And so that's why we got those smoky marbles. Just like a snowball, it just pushed that iron forward. That iron collected manganese and sand and other things that just made it harder, and it just pushed it out. And that's why we have all that white sand, is because the hydrogen sulfide shot through it when it was wet and pushed the iron forward. Plus, it put that iron whole again because it was rusting, but now it's whole, and that's why we have those smoky marbles, is because that hydrogen sulfide grabbed that iron and just packed it all together. Way cool, huh? So there's probably something else I wanted to say about the hydrogen sulfide. So not only do we have the white sandstone from hydrogen sulfide, we also have it from leaching. So when you go to Zion National Park, if you look at, we have cliffs in Zion that are almost 3,000 feet tall. But if you look at the top of that cliff, it's white, and down at the bottom it's red. Because that sandstone is so porous, it allows water to soak through it at about 6 inches per year. And while that's soaking through, it's actually pushing that iron down. So it's not It's not like the hydrogen sulfide, because the hydrogen sulfide will make it whole again. That water is just leaching the iron out. So when you go to Zion, look at the cliffs. Up on top, it's all white because it snows and it rains. The water soaks through and it's pushing the iron further and further down. Way cool. So the stream bed we have in Snow Canyon, it's mostly white sand, and a lot of people think, oh, it's just because it's white because it's coming from the White Mountains up here in the north. Well, that's partially true, but we have far more red sand that pours into the bottom of that valley than we do white sand that comes from the north. And it's just, generally speaking, it's just leaching that iron out as it washes down through the dry riverbed when it rains. The other cool thing is you can actually go out in that dry riverbed and it's perfectly white sand, but if you dig down a little bit, it starts to get red again, just like the cliffs in Zion. So the top is white because the water's soaking through, but the further down you dig, the more red the sand becomes. So we have more red sand in those riverbeds than we do white sand, but the water's just leaching it out. Any questions on that stuff? Hey, yeah.
So on the Monkey Marbles, my understanding is that they are precipitated around a carbon atom. That's
Yes.
what
So that is true. Yeah, and if you actually find one that's broken open, you can look at it just like if you go out when the snow is really wet and you roll a snowball, you can actually see the layers of snow as you roll it. And it's the same thing with the Monkey Marbles. So it starts around that little carbon atom, and then it rolls it forward. But that's that gas being pushed through it, hundreds and thousands of miles an hour, depending on where the cinder cone popped up, and it pushed that gas through the wet sand. So there's a picture of Candy Cliff. I always forget what we call it here, but Candy Cliff. You can see those different layers of sand. And when it was wet, the coolest part about this part, right in, I have to look at it, right here. You can see that wet sand is actually a flat layer like this. It got hit by a meteorite, and when it did that, that wet sand sucked in like this because that meteorite sucked it in when it hit it. And so that's why we had that heart shape out there. And if you look at the bottom of that heart shape, all the sand is fused together like terracotta because that meteorite was so stinking hot that it burnt the sand, and so that's why we have terracotta out there. But it was just all wet sand 180 million years ago. And then the dinosaurs were here for 60 million years, so from 180 million to 60 million, that sand stayed wet. So it didn't turn solid until after the dinosaurs skedaddled. So that's why we have dinosaurs.
Thank you,
I hadn't
Giuseppe.
heard the explanation about the heart.
That's way cool, isn't it?
Yeah.
Yeah, I actually took two different people out there. I took a meteorologist and a geologist. And the geologist said, man, this is so weird because the sand would have been wet and something had to suck it in to make it form like that.
Right.
And then I went out there with a meteorologist. He's like, oh, this was struck by a meteorite. I was like, that makes perfect sense. Yeah, wet sand, it got fused together, turned into terracotta. And there's several spots out there that you can just see where something hit it and it fused all that sand. You have this big tube of terracotta that's out there. Just way cool. To think that it was all wet.
And the meteorites all got picked up a long time ago.
Well, see, and I've wanted to go out there with a metal detector and look for them because, yeah, you know, there's
Some old boy's been out there, because meteorites are very bad.
Oh yeah, they're very bad.
Giuseppe, thank you.
Awesome.
Thank you.
Thank you.
It's my pleasure.